Last time we talked about Z-scores. Remember the standardized Z-scores? It was a way of taking two dissimilar pieces of information, but standardizing them in such a way that you could tell if one was better than the other. So I guess for a kind of overlap, I'll do one of those. Tests are always good. So two people, one in class A, one in class B, and they both had the test. And this person got 75, and this person got 80. So I guess superficially you would say that this person did better than that. But we know that it's much more complicated than that. So I'll put in a mean of 70. And here I'll put in a mean of 60. And so that maybe not look, well, it might still look like that's even better, right? You know, lower mean, but this person done a lot. A bigger mean, this person only did a little bit better. So right now, I think, would you agree B is winning in a kind of superficial way? But you can't be sure. You really can't. Until you know one other piece of information, and that is the standard deviation. And when you put that into the mix, the way that you then compare them is by getting the Z-score. Let's see what the Z-score of this person is. It's X, the data, take away the mean, divided by the standard deviation. So this is 75, take away 70, and I'm going to divide it by 2, and this comes out to be 2.5. And this one, same formula, but with different values being used. 80, take away 60, divided by 10. This comes out as a 2. So actually, it's harder to get 75 in this class than it is to get 80. And it's really all to do with the fact that in this class here, the standard deviation was very small, 2. So that meant pretty much everybody got, 70, 72, 74. You can imagine they were very close to each other. Whereas in this class, wasn't there a huge variation? So there were quite a lot of people who probably got 80, right? It wasn't that hard to get. There's not that many people. And how do I know? Bigger Z-scores are harder to get than small Z-scores, right? Just as a little addendum to that. What kind of Z-score counts as an outlier?
3 or more, right?
3 or more. That's how we do it. Whether the book says 2.5, I don't care. It's really 3. Right? Now, you can also work backwards. If I tell you the mean, this is an IQ story, and I tell you the standard deviation, and I then give you a Z-score, you can find out what that person's score is, even although I'm only telling you their Z-score, and you can do it because there's a formula that kind of works in reverse. It's this guy here. And in this case, the mean is 100, 1.3 times 10. That would get you 113. So far, so good. So if I give you a person's score, the mean and the standard deviation that they came from, you feel comfortable you could find what the Z-score would be. And if I told you the mean and standard deviation and I gave you a Z-score, do you feel comfortable you could work backwards and find out what their score is? Does that seem, as a process, pretty straightforward? We good? Okay, then let me show you, if I can, some questions from the homework where they do that, so we can see how the homework gets asked and what they kind of look like. Right, so we should be looking at, this is 6.2. This is question 6. Find a Z-score when the data is 27, and here's the numbers you need to use. You see them up there? So that one there, for instance, question, a score of 23, wouldn't that simply just be 23, take away 27, divide the whole thing by 4? Now, can you work in reverse? Sure. If there's a Z-score, I'm calling it data, they're calling it raw score. So if you ever see the word raw score, they're saying data, right? Just another way. So if I tell you the Z-score is -2 and you wanted to get the raw score, wouldn't you do the formula that you can't see, but I'm reading out to you? X equals mu plus Z times sigma, and that would get you the score. There is a couple of things I can tell you. Won't the answer to question C, won't it be less than 27? And how do I know that it's definitely less than 27? What
because
about,
it's a negative number?
Yeah, in fact. And if you want to think out roughly, what is a Z-score? It's how many standard deviations away from the mean you are. So see this Z-score in -2, that means that you are 2 lots of those, that's 8 away from the mean. So I could do that in my head, the answer would be 19. So a Z-score is how many standard deviations you are away from the mean. So if you want to get your head around what this thing is, that's one way to look at it. That's just an English version of that same story. Here's comparing two people. I get a feeling I may have done this before. Did I do this question before? I know I did it with mother class. This new? Don't recognize it? Wave at me, say hi.
New.
They're new, okay, good. Right, here's a whole load of people. Here are their Z-scores. Now, which of these students scored above the mean? Well, above means positive Z-score. So you would say Robert, Juan, and Linda. What about Joel? Did he do above the mean?
No.
He got exactly the same number as the mean, didn't he? Even although you don't know what the mean is, you know he got the same as it. And people below and so on and so forth. Now, here they tell you the mean and the standard deviation. And what you're going to do here is you're going to take each one of these Z-scores, like 1.22, for instance, and convert it into an X number. So for instance, if I was doing this one, the calculation for Robert, let's see what Robert is, 1.22. So for Robert, it would be 156, which is what the mean is, plus 1.22 times 17. And whatever that came to, that would be the answer. That would be the raw data, as they call it, right, for him. Make sense? Okay. So by all these, oh, actually, that's him showing you the whole calculation. Right, new guy. Let's show you something that we're going to be doing a fair amount of. And that is how to convert from inequalities that use X, the raw data, and convert them into an equivalent inequality in Z data. So imagine you had a mean of 100 and a standard deviation of 10. I like those because they're really very easy to work with numbers. Now, right in the middle would be 100. And then the
screen.
Oh, thank you. Right, so the IQ's mean of 100, standard deviation is 10, and I'm basically just creating, you know, the 3 standard deviation normal distribution guy, right? That's what he looks like. Now, underneath it, I'm going to do, oops, that's a wobbly one. I'm going to do the standard normal distribution. So you just stick the word standard in front of normal distribution. What does that look like? Well, they all have the same value. They all have a mean of 0 and a standard deviation of 1. Now you might think, well, what's the connection between the IQ scores, right, and what the distribution looks like, and the standard normal one, which looks like this? Well, do you know if you turn each of these numbers into their z-scores, what you end up with are these numbers. Can you see how that would happen? Wouldn't 110 be one standard deviation away from mean? That would generate a z-score of 1. So although these may have different scales along the bottom, essentially the information that is in here and the information in here are actually equivalent, right? They tell you the same thing in different ways. So suppose I went and said to you, I would like to know the percentage of people who had an X score bigger than 112. So on my picture here, can you imagine 112 was there? The percentage of people that have that would be actually the area. So if you took the area under this curve, that would be everyone. But this piece here, that would represent all the people who got a score greater than or equal to 112. Guess I should put equals in there. Right. Now we're going to do a conversion. What would that look like with Z's? Well, the only thing you need to do is find out what 112 looks like as a z-score. Well, should be able to do that. 112 x, take away mean over sigma. And I get 1.2. If I go here and I do 1.2, that guy is the same size as that guy. Although it might not look that interesting, that's actually very powerful. What it is saying is that every normal distribution in the world, you can convert it into a standard normal distribution. And anything you want to know about this guy, you can find the equivalent in this and the answers will be the same. So if this guy is 20%, that's 20%. If this guy is 4%, this guy will be 4%, which means you do not need an unlimited number of pictures of this with all the, you know, that little 68, 90. You don't need that anymore. All you need to do is convert it into this. And just to make life even easier, SALT does it all for you. So you can actually get the answer without too much trouble. So in this particular case, what was the answer before I threw it away? It was, 1.12. There we go. So let's just get practice at converting X's, this kind of story, into Z's. So I'm going to give you a mean of 50. We're going to do a standard deviation A2. And we're going to look at what they look like in X's and what they would look like in Z. So X greater than or equal to 47. X less than or equal to 41. X greater than or equal to 46. S less than or equal to 52. And then to finish with, X between 40 and 50. Now for every single one of these, there's a load of homework questions where you convert them into what they would look like in terms of their z-scores. Now the first thing you should notice when you do these is that whatever the relationship is, it's the same relationship. So you just replace the X with a Z. That way you'll not get mixed up. So won't this be going that way? Won't this be going that way again? Won't this be going that way? And this one in the middle looks something like that. Now for every single one of these, you then go to the number and you will use x take away mu over sigma, right? Just your normal conversion guy. Now I'm going to try and do these in my head, which is definitely a bad idea, but I'm going for it anyway. This guy is negative 1.5. This guy is negative 3. This guy is, what's that? Negative 2. This guy is 1. And this guy here is negative 5 and 0. Now you can double check that, but hopefully I got those all correct. So if I gave you a question like this, do you feel comfortable you could convert it into the equivalent Z story? Raw data story, equivalent Z-score story. And that one there does look like it's wrong. Yeah. Okay. Next one is too much work for me to write down, so I'm just going to show you the question. It's quite wordy, and then we'll return back to our paper and think about what the solution might look like. This is question 12. Tree-ring dates are usually used extensively in archaeological studies. I remember the Pueblo one before. At one site, they have tree-ring dates for many samples, and they had a mean, call it mu1, which is 1264, and a standard deviation of 40. So I'm just writing that down. And then at a second different site, the mu2 is 1110, and the standard deviation is 37. Okay. In the first area, they got an object, they're calling it X1, and they dated it as 1205 according to the tree rings, their best estimate, and X2 they dated as 1249. And we're being asked now to convert these to their Z values, which I'll do in a few moments. And then which of these is the most unusual? So it's equivalent to John did the math exam and, Mary did a math exam and, who got the best score kind of thing. So we're looking at which one of these is the most unusual. Well, let's do the first one. $1,205 years old, take away that mean, divided by 40. Oh, here's a mistake that I'm about to do, a deliberate mistake. 1205, take away 1264, divided by 40. That's wrong, which I think when you see a Z-score of 1173, you probably should guess it's wrong. What on earth went wrong?
Dividing 1264 by 40 first.
Right. So if you want to do it as a single calculation, you need to put a bracket around it. And that mistake is a little bit easier to make when the numbers are really small, because the Z-score doesn't look that weird in those cases. Still wrong, but it just doesn't look weird. Now, does this Z-score look good? Yeah, reasonable. Negative 1.475. Okay. Right, the second one is basically just going to be done with a lot of twos. 1249, 1110 over 37. 1249, take away 1110, enter, divide by 37. That's another way of doing it correctly. And whoa, I wasn't expecting that. Which one of them is the most unusual?
1/3.
One, I'm not sure what your answer is. Do you mean
The
this one?
1/3. Yeah.
Oh, okay, gotcha. Yes, I agree with you. Big Z scores are highly unusual, right? The bigger, the more unusual they are. Nothing wrong with being negative, right? It's just not that big a negative number, right? So this one is more unusual. Can we just pretend in a different question that this guy here ended up being negative 4.12, just for argument's sake? Which one of these two, I know both are unusual, but which one of these two is even more unusual than the other one?
The negative 4.12.
Yeah, we don't care if it's plus or minus, don't we? Just care how big it is. That's probably only going to happen about 1 in 1,000 times. This guy here will probably only happen 1 in 10,000 times. Although it's only a small difference, right? It can have a huge effect on how likely it is. Do you know if you get a Z score about 6, you know, that kind of size, you're talking about somebody winning the lottery unlikely, like 1 in 20 million kind of thing, right? So if a Z score comes out anywhere below 3, it's definitely an outlier. But it's a kind of exponential growth, right? A Z score of 6 is not twice as unlikely as a Z score of 3, right? It's like 100 times more unlikely than a 3. And a 3 is very rare. So you can imagine 100 times something even rare, right? Okay, so what would that be the equivalent? That would be the equivalent of an honest politician has a Z score of 3. And an honest politician who doesn't lie would have a Z score of 6. Right, that kind of thing. Do you get a feeling I don't appreciate lawyers? Lawyers, I don't appreciate lawyers either, but politicians. You did get that impression, right? Just thought, okay.
Just a little bit.
Just a little bit. I think it kind of, it's subtle, but eventually you'll cotton on to it. Okay. We are now going to do some really quick questions. And the reason they're going to be really quick is because of this lovely button. I love this button because it is going to do almost all the work for us. It says sketch the area under a standard normal curve over the indicated interval and find the specified area and round off your answer to 4. That's just, it says that all the time. Basically, you want to know the area to the right of Z equals 0, hit this button. And I'm going to have to move this page over here. And that's what you see. Now, I wanted it to be greater than 0, didn't we? Oops. Well, let's just do it the easy way. There's 0. What do you think that answer is going to? Well, you can't think because it's there. Do you see that the answer is 0.5? Well, of course it is. Isn't to the left 50% and 50% as a decimal is 0.5? Right. Now, let's move this guy to, let's say about there, which is, okay, tweak it a little bit. You know, it's quicker just to type it in, I think. There. Put the wrong guy in there. anything to the left of 1 is about 84% of the time. Let's put an outlier in. There's 3. Wow. Right? So everything that side, right? Anything smaller than a z-score of 3 is going to be, what, 99.865% of the time? I can change it. Suppose I go to the right-hand side like this. Okay. Come back. And I change this number here to 3. What percentage of z-scores are bigger than 3? Do you see how tiny that answer is? It's not even 1%. Can you see why 3 is an outlier? It's such a rare event. And that's roughly 1 in 1,000. Let's put in 6, because I can. Oh, the answer is 0. Well, actually, it's not technically really 0. It's like 0.12 nothings and a 2 or something, right? It's so darn close, we're calling it 0. But what I like about that particular question is that the answer we got by just going to the salt. Right, so let's see. The area to the left of z equals negative 1.33. So I'm going to click on this guy. I'm going to bring this thing over. And it's going to be to the left of negative 1.33. Yep, isn't that picture to the left in negative 1.33? And the answer is that guy. So if somebody says, what's what percentage, or in this case, probability, but same thing essentially, you can use this particular diagram. Let's just play about it. What happens if I do a between? Well, what I need to do is I need to have a start x. So how about a start x, negative 1, and a finish of 1? Technically, these x's are z's, right? Isn't that 1 standard deviation away from the mean? And shouldn't that be 68%? And guess what? Would you agree that's pretty close to being 68%? I think I did this with one of my 2 classes. Hopefully it was you. Can anybody remember what 2 standard deviations would look like? What percentage?
95.
And the answer? Pretty close, right? 95. Now, the third one I don't remember. I don't expect you to remember, but maybe somebody can say what's 3?
Was it like 99.7?
You nailed it.
Something like
It's
that?
exactly that. It's not even something like that. It is that. And guess what? Would you agree that's pretty darn close to 99.7%? So do you see that interval that we got on Monday that had 68, 95, and 99.7? Do you see that wasn't just plucked out of the air? Do you see it came from the z-scores? Z-score of 1, Z-score of 2, Z-score of 3. It's the equivalent. And that's pretty cool. And here are just basically a whole load of questions where you hit the salt button and you do, I should pick. Okay, let's do this one. Between 0 and 2.61, coming up. Between 0 and 2.61. So I'm going to do a between 0 and 2.61. And the answer is That guy. I'll try and copy him. And I'll put it here. And they want the answer rounded off to 4 decimal places. So
That's the wrong one. It's the one above.
Uh-oh, thank you. And it would fit in there. So although there's a lot of questions here, can you see that they're probably going to take you about a minute each? Right? It's going to be bigger than this Z-score, less than this Z-score, between this Z-score. And if you hit that lovely salt button, can't you just go there and play about with the, you know, the features that it's got to get the numbers that you're looking for? And that is a pretty cool thing. And they're just a whole load of more of the same. So, oops. Yeah. I'm thinking there are about a dozen of these guys, maybe a little bit more. But by the time it's finished, you should be really good at using salt to find areas in a standard normal distribution, right? Bigger than 1.2, less than 0.5, between 1 and 7, you know, anything that they ask for. And that's section 6.2 finished. Any questions about it before I close this guy off? Do you feel comfortable about getting Z-scores and X-scores and using salt?
Could we possibly go over it one more time?
Sure. Let's pick one. I'm at this one here. So we're being asked to find the probability that you get a Z-score, which is the area, it's the same thing, of a Z-score being greater than negative 1.51. So I'll hit this button. And what will happen is that this will appear. And I want it to be bigger than, and I want the number to be, I've forgotten what the number is. Is it 1.71? Negative 1.51, okay. So negative 1.51. And do you see a little picture for visuals? And the answer is down here. And so 0.9345 if you round it off, 0.9, did I say 93? I think there's a 0 in there. Oh, okay, yeah, it is. It's 0.9345. And here are 4 pictures. And one of those 4 pictures was the guy I had. I'll bring him back just for a second. I don't know, can you see him? And would you agree that that picture there was essentially the same guy? So what this is telling us is the chances that you get a Z-score from any normal distribution you like that's bigger than this number is going to happen about 93.45%. Right? That's me converting that into a percentage. And visually it looks like that. And you can see that's a big chunk of all the things that could happen. That's cool. Are we okay to move on then? Okay, then I'll buy you that one. I've got all sorts of pages to close now and hopefully open the right one at the end of this. So we're now going to get 6.3 hopefully done. And that's kind of my goal, to try and get it done. That way Friday we can do 6, 4, 5, but 6, 4 and 5 are together as a single homework. And in these stories, we are going to use salt a lot as well. But before I start looking at their questions, let me show you how it works.
When we take a test, is salt going to be available as well?
Yes. So those are probably not going to be the questions that are going to cost you a lot of time or hopefully effort, I hope. Right. Let's suppose that we collected a large load of data on the heights of people in Scotland, males in Scotland, and the mean was 65 and the standard deviation was 2 inches. Now, if I draw just for visual, can you imagine what that might look like? 65, 67, 69, 71, and then going the other way, it would be 63, 61, and finally 59, right? So that's kind of what male adults in Scotland, the distribution of the heights, right? We're not all the same height, right? Not all Americans are the same height either, right? But we tend to congregate closest to the mean, and then we drift, right? Fewer and fewer taller people, right? Fewer and fewer shorter people. And suppose I then asked you to find the probability that you just randomly go out in Scotland and pick somebody and their height is bigger than 67 inches, bigger than or equal to, doesn't matter. How would we go about doing that question then? Well, if you looked at my picture, you can see 67 is there. So I guess all I need to do is find out this area, right, forever, right? But that can be really awkward and time consuming. And wouldn't it be so much nicer if Salt would do it for me? Right? So since I've made up my own numbers, I'm now going to return to the homework, and I'm just going to use their Salt. So are you looking at the Salt thing? No?
Yes.
Okay, so
the
I'm going,
homework.
yes, clicking on it. This is the guy, can you see him? Right, now my picture was greater than, 67. So I had to hit the right tail, so it's greater than. And then over here, I'm going to put in 67. Up here, I'm going to put the mean height was 65, and the standard deviation is 2. Do you see that I had to give a little bit more information, right? And don't know why that changed, but it updated weirdly, right? And now put in 67 and it should be happy. There. So you will type in 67, whatever the mean happens to be in your story, to the standard deviation in your story, and we're after bigger than 67. I can see visually what that is. Now, there is the answer as a decimal. Would you agree? It's what, 0.15866. While I'm at it, let's do a couple more questions and then we'll return to the sheet. I'd like to know what percentage of Scottish people are less than 5 feet, which is 60 inches. And I'd like to know what percentage of Scottish people can play basketball. And I'm going to just make the assumption that you have to be at least 6 foot to play basketball well, right? I know that's not true, but just for my story. So less than 60 is going to be my next one, and greater than 72 is the next one. Now, the mean and standard deviation aren't going to change, so I only need to change what the heck's going on here, right? The probability thing. Right, if you want less than 60, which one of these 4 dots do I need to hit to get the software to be ready for me?
Left.
Okay, and you see how it changes here? And I want this number to be less than 60. And if I click on that, the answer comes out that it's 0.00621. And now I want to be bigger, so right tail, and I want you to be bigger than 72. 2. And the answer to that is 0.00023. Do you see that I can do anything I like now with this salt? Can't I find a percentage of people, which is the same thing as picking one person at random and getting an event, right? Percentage, totally equivalent. And these are my answers. And just get myself set up here. Right, to 2 decimal places. This guy here is 0.16. To 2 decimal places, isn't this guy 0.01? And this fella, to 2 decimal places, is almost unheard of, right? 0.00. So as long as you've got this salt guy, isn't it just a matter of knowing how to write the question down, converting it into a picture? Well, use salt. That'll convert it into a picture, and it'll tell you the number you want, and then occasionally you round off. Okay. So far, so good. So let me, I know I'm bouncing about like a yo-yo here, but I guess it's what I have to do. Let's just look at some more questions. Suppose 80% of the area under standard normal curve lies to the right of Z. Is Z positive or negative? So you've got to visualize this. You've got your normal curve, you've got some point, and to the right of it, that's 80%. Would the Z score be positive or negative for that to happen? So imagine a line and everybody to the right, and that was 80% of the whole thing. Would that number, the Z number, be positive or negative?
Negative?
Yes. Do you want to see a picture of that, or does that make sense? Not all of you look comfortable. Let's just get you dizzy and move back and forth again. Right, there's my standard normal. Somewhere this has to be 80%. Do you see why it needs to have a negative Z score? Right. Suppose I told you that to the left, yikes, I can't even write English today. Suppose I said to the left was 90%. And then a different question, to the left again was only 40%. Right in the middle, right, at Z equals 0, 50% this side, 50% that side. So if to the left is going to be 90%, won't the Z have to be over here somewhere? So in this case, won't the Z be positive? Right, a little bit trickier, this one. To the left is only going to be 40%. Where do I put the Z this time? Left, negative or positive? So imagine this is, right. So I was going to say, imagine this pen was where the Z goes. And we're talking about everything to the left here. Can you imagine over here it's going to be bigger than 50%, isn't it? To the left. And then you get to here and it's exactly 50%. Won't you have to move somewhere over here to get 40%? Make sense? Are we good? You look worried. I don't like worried.
Wait, which percent would you have to be positive again?
Depends on this number as well. 90% you'd need to be a positive Z-score for that to be a 90%. If it's a 40%, the Z would be a negative number in this case. So it depends on the question. It doesn't really, that's not the reason it's positive or negative. Isn't that along with this together is the reason it's positive or negative? Right. Does that help? Okay. Suppose you wanted to know if you had a whole load of data and you wanted to know, was it normal in shape? Because if it is, then you're going to have a lot of good stuff you can do with it, right? Mean, standard deviation. Then you can do predictions like who's going to be an outlier, what percentage of the data is bigger than this number or less than that. You can do all those cool things. But you have to know that the shape you've got is normal. So you can collect a whole load of data. How do you test if it's normal? Well, software does this for you, but basically you find the original data value, right? You know, the X is 10, the X is 20, let's say 30, whatever it is. And for every data point, you find out what its Z-score is. And if you get data that is linear. Now, it won't be a perfect straight line because in real life data is never perfect, right? There's always a little bit of wiggle room when you ask this person, but you didn't ask the other person, right? But if it's linear, if it looks like a skinny sausage, then you can be sure that your data is normally distributed, and therefore you can do all the cool things that we can do with that kind of data. Right? So let's look at the question that does that. Here is a whole load of data. This is what the histogram looks like. It's not perfect, but in real life data isn't. Real data is never smooth and straight, right? It's always wiggle room. This particular histogram, if you look at it, doesn't it look a little bit off? And you sometimes will kick data out because it's a little bit off and you think it's not good enough. But over here, it's called the normal quantile plot. Do you see that this data is pretty straight, isn't it? You see this sequence of dots is pretty much, isn't it a really skinny sausage? Which means even if it doesn't look particularly normal to you, it's normal enough, or it's close enough to being normal, to be okay to use that in all the calculations. And since this is a really useful thing to be able to do, don't you want your data to be at least good enough normal so you can start saying, if you get bigger than this, you're an outlier. Or if your temperature is bigger than this, then you're in trouble, right? How do you do that? You collect lots of temperature data, and it's going to be high and low and in the middle, and some people are healthy and some are sick. And hopefully it matches up with this thing. And if you see this as linear, go for it. Histograms are deceiving because human beings are programmed, their brain is programmed to see patterns, and it's also programmed to see when things don't fit a smooth pattern. So if you just forget that curve's a distraction to me. If you look at the histogram, doesn't that guy there kind of make it look wrong? It shouldn't be as tall as that. Shouldn't it be a little bit shorter? Should be roughly about here. But if you forget about that, isn't most of the data up and down the way it should be? But your brain focuses on the things that don't match, and that makes you kick out things. The nice thing about this is, can't you see that it's pretty straight? Now, if it's not straight, your brain will detect that as well. Can you imagine the dots went dot, 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 dot. It went like a snake. Can you imagine the data? Still goes uphill. It has to go uphill. But can you imagine it had a kind of curvy snake shape to it? Your brain would see that, wouldn't it? Quite easily. And that's bad news. Because if it did look like that, it's not normal. And you can't do all the clever stuff. So if it's straight line, go for it. Here's a whole load of information about this data. That's its main. Got a guy here called standard deviation. Tells you all sorts of cool stuff. Let me do something that's distracting the heck out of me. Got the answers on this. Is it gone? Yay, they've gone. Right. I think I'll make this bigger because I really don't know what you can see. Yeah. So assume that the data is normal. Great. And the mean is 8. The standard deviation is 2. What percentage of people would have a score between 7 and 11? Or what is the probability that someone gets 7 to 11, right? Equivalent question. Better write that down because I'll forget. The mean is 8, the standard deviation is 2, and I want 7 to 11. Well, the easy part, hey, why is that answer still there? Here's salt. Oh, shooting space. I need to shrink it to get what we need. Aren't we wanting a between? The mean in this question was 8. The standard deviation in this question is 2. And I want from 7 to 11. And the answer is, what, about 0.62466 rounded off to whatever accuracy they want. That makes sense? Right. I'm going to keep that picture for a second, but I'm going to return and we're going to make up our own. Suppose that there's a class that you take and there's only a final exam. And the final exam, the average was 60. And the standard deviation was 15. Right. And the professor only gives A's, right, to people who get a score greater than or equal to 90. And he gives a B to people who get anywhere between 80 and 90. And he gives a C to anybody who got 50 to 70. And lastly, you fail the class if you get less than 50. So what we're going to do now is find out what percentage of people get A, B, C's or D's, or A, B, C's and fails, right? Gut feeling, what kind of percentage do you think get A in this class? Tiny? Okay? Quite a lot? What's your gut feeling? What do you think, Erica? I cannot hear you.
60%.
Ooh, interesting, right? How many do you think get B's? Anybody? You think a lot, some, tiny amount?
Probably a lot.
Okay. How many get a C
Not very many, probably.
and fail?
A lot.
None.
A lot. Right, so the thing is, it is quite hard, isn't it? Your gut feeling is, I don't really know. Most people will probably be honest and say, I really don't know. I'll be honest, I don't really know either, but we're going to find out. So I got this here, so you won't see it in a few seconds, but I'm going to use the numbers that are here, and we're going to return to Salt, and we're going to let Salt figure that out for us. Now, since this table is here, can't I just revamp it and put in a 60 and put in a standard deviation of 15? And you have to be greater than, right? So how many people have a score bigger than, that's to the right, and bigger than 90? And let's see. Ooh, not good. 0.02. I'm just going to round this off to 2 decimal places. Do you know only 2% of his class is going to get an A, which means it's lucky if one person gets an A. Tough class, right? Now, the next one was 80 to 90. Isn't 80 to 90 going to be a between? And I'm going to make this 80. And I'm going to make this 90. And I don't know what this is going to be until I hit off that. And the answer is 0.068, which is what's 0.07 roughly? Which is what, 7%. Not good. The next one, well, maybe I can get at least a C, right? I want to pass this class. Maybe I can get a C. Well, 50, all the way up to 70 is going to get you a C. Wow. 0.49501, basically that rounds up to 0.5. So actually half the class will get a pass. It'll just be a C. Now I can actually tell you what the last answer is going to be because I already know the first three, 2, 7, and 50, right? So won't that add up to 59? So 41% are going to fail. So that's me just basically being lazy, right? But I could do it. So now we're going to return, and you'll see the answers I just gave. Do you want to be in that class? If he's doing another one next year and he grades the same way? That's going to murder your GPA, isn't it? Agreed? Suppose you're not very good at his subject. You might take his class, because isn't there a good chance you're going to pass? Well, more than half get a C. So if you're kind of average, and the chances are you're just going to get a C, and if that's all you're looking for, I guess that would work. But if you want to get a 4.0, 2%, you know, you'd have to be the best in the class, right? That's the only way you're getting it. You see, we've got ways now of looking at quite limited information, right? All I know is that the mean was 60 and that the standard deviation is 15, and I know it's normally shaped, right? That's it. With only those, can't we now get pretty much anything I wanted? Bigger than this, what percentage or less than that, what's between here and here? I can do any of those. And I think that is a very powerful tool that we now have at our disposal. Okay, and Well, I'll just, I don't even know where we are here. I'm just going to return here. I'll talk through some of these ones because I think we've covered enough for you to get a gist of what we're going to do. So if you tell me the mean and you tell me the standard deviation, can't you use SALT to get the percentage of people between 7 and 9? Imagine me going in and changing the mean, standard deviation, start and finish, and we're done. I think I might make this bigger since you just want to be able to read the question. Right. Mean standard deviation between 8 and 12. Mean standard deviation bigger than 30. Mean standard deviation greater than 90. Do you want me to do any of those, guys? Or do you feel comfortable about just going to SALT and make it a half? Do you want to see one more?
Yeah, let's see one more.
Let's see more. I'm looking at 11, so I might as well do 11 then, right? So in question 11, the mean is 104, the standard deviation is 10. What percentage of people get a score greater than or equal to 90? Right, that's what it says. I better write that down because of my memory. The mean is 104, the standard deviation sigma is 10, and we want to know what percentage of people get greater than or equal to 90. So I'm going to hit SALT. Well, and the mean is 104. The standard deviation is 10. And I want a greater than, don't I? So I want a right tail. Can you see greater than, the little picture? And I want to be greater than 90. And the answer is, well, 0.91924. 0.91924. And now I would go in here. I do that. And then I'd say, oh, you want 4 decimal places? That means you don't need the 4 in this case. And there's your answer. So far, so good? We good? Right. I want to do one more because I just got a thought. Does anybody here know their IQ score? And they want to share it? Very rare thing, but does anybody know the IQ of somebody else? I'll take that number. And you don't even need to tell me if it's your brother or just somebody you know about.
137.
137, that's a pretty bright guy. Okay, I want to know how many people have an IQ bigger than 137. And can you see it's so tiny it hardly appears on the picture? It is 0.0001 roughly. 1 in 10,000 people will have that kind of IQ or better. Was that just a made up number or did you know someone that had that IQ?
I believe it's my dad.
Ah. Well, you better hope you got some of your genes, G-E-N-E-S, from your dad.
I think I do, but I got the dyslexia from my mom, so kind of balance.
Yeah. Dyslexia, I mean, there are all sorts of spectrum in dyslexia, and there's numerical dyslexia, which means that they have problems with digits and, you know, computation, and then there's the kind of literal version of it where it's words and, you know, reading that bugs the heck out of them. But it really isn't a big deal anymore. I have, because I'm going to share it with you, I have 2 nephews. My sister Pearl has a lot, so she has 7 kids, but 2 of her boys both had the, you know, the written version of dyslexia, right? It's the written word. Great at numbers, didn't bother numbers, right? But, you know, words and reading and, you know, the brain is just the way your poor brain is kind of wired. And anyway, they were born in the right time, because computers have things called spell checkers. One of them, for instance, uses a software where you talk and it writes what you say. So he doesn't even need to type it. And a spell checker will auto-correct it. And those two people I'm talking about, one of them is a chemistry professor at Glasgow University. Hasn't bothered his career. And the other is a research scientist who now works for the oil industry, I was just told. Used to work for Kohler, and now he's a research scientist, and he does fluid mechanics. Never bothered him. I mean, don't ask him to write anything by hand. He's like a doctor. You can't read the writing, but didn't really hurt you. I mean, so we're lucky in this world that we have technology that takes a lot of the edge off that, which is kind of cool, isn't it? Makes your life a little bit easier. And I drifted, as I do. So now we are going to return for the last piece of the puzzle. And we are going to look at a question backwards, for want of a better description. So I'll show you what I mean as soon as I get this thing on. Let's suppose we have a mean of 100. And we'll stick to my good IQ because it's nice numbers. We know how to go, what's the probability that X is greater than or equal to 137, right? We just did that, right? And the answer to that was roughly 0.00011. And if you can imagine what that looks like visually, there's the 100, there's 110, 120, there's 130, there's 140. Can you see it's a tiny little whatever's left down here? Tiny little bit. That we can do. Here's the puzzle. I would like to know what value of X gives you that number. So in other words, if I told you that this number in here was 0.00011, could you find the 137 from me? We know how to go from 137 to here, but can you work backwards? Do you see what I mean now by the reverse puzzle, right? So what would that look like? So it would be, what's the probability that you get an X score greater than or equal to unknown number, and it's equal to 0.00011? Now you think about how could you do that? Well, if you tell me the area, isn't there a number associated with that? Isn't the job to just figure out who he is? And the good news is that salt will do it for you. So, guy's 100, sigma is 10. Here's my picture. There's a guy over here. Give me a nice reasonable number for that percentage and we'll go hunting for it. Do you want it to be 5%, 12%? Give me a nice number and we'll use that as our question.
3.5.
Okay. So we would like 3.5%. Of course, I need to turn it into the decimal version of it, but that's fine. Right. So how can I get the missing IQ that goes here? Now, I know that's 100. If you were a betting man, would you agree it's probably in the 120s? Maybe 100, maybe 130, but probably 120s. Let's see how good a guess I am. Well, there's a mean of 100. There's a standard deviation. Right. I'm going to go here. And, we're doing to the right, and I want this number to be 0.035. There's my picture. And guess what? Do you see that number appeared in the box? An IQ that would make that happen was actually a little bit less than the 120s. It's about, what, 118 roughly? Oh, I'd like to know what kind of IQ you need to be in the top 10%, right? I want to be in the top 10% of IQ people. Well, wouldn't that be a matter of making this number 10%? And you need an IQ of what, about 123? That's kind of cool.
Wouldn't that be the top 1%, or would that be?
Oh God, you are right, top 1%. Too many zeros there. I put it in the wrong place. Where is it? No, I put it in the right place. 112. Thought I'd done that. Did I fix it? Yeah, it's fine. It's 112. What kind of IQ do you need to be a football player? Well, I know that football players have an IQ in the bottom 40%. I made that up, by the way. Bottom 40%. So switch over to left tail. Make that 40%. What kind of IQ, what do you need? Do you need an IQ of what? Of 97 roughly? Now, if they don't use IQs now, they use much better tests. But in the olden days, they used to use IQs to tell if you needed remedial help, right? You needed extra help at school. And let's say you needed to be in the bottom 25%. Then your IQ would have to be 93 or less. So do you see that you can change this number and it'll tell you what X is, or you can change this number and it'll tell you what the percentage is. You see that the software works in both directions. Suppose I decide that only people in the top 1% get to come to my party because I'm an elitist. And I'm having a birthday party and only the top 1% come. So now I can put that guy in. Oops, top 1%. You'd need to have an IQ of 123 to get in. Now, have you heard of a company organization called MESA? M-E-S-A. Mensa, I should say, not MESA. Mensa, M-E-N-S-A. It's an organization that you can join, but you can only join it if your IQ is above a particular value. And so you can go online and look for it. You can take a little practice IQ test to see if you might get in. I'm a great believer in tests that I'm good at, and a great disbeliever in the ones that I am bad at. So when I did take an IQ test as part of the psychology class, and I won't share my IQ because I don't want to, but it wasn't that good, what I thought it should be. And so I immediately said, IQs aren't that good. And then I realized that they had different types of IQ tests. And one of the IQ tests they do, I got to do, and it was a math symbolic version. It was the kind of question where, here are 3 numbers. What would the 4th number be? Here are 6 shapes. Which one is the odd one out? You know, things that were symbolic in that. And I did really well in that. So I then decided that that was a really good IQ test. But the other one, which was, you know, if you've ever taken one, they say things like, circle is to sphere as square is to, and then you fill in the missing words, right? Or they give you 5 words and they ask you which one is the odd one out, right? So there's a lot of literal type questions, and me and English were never friends. Okay, and I have drifted yet again, but we are getting close to the end, so that's good. So, I'm just trying to find one Are you looking at the homework or are we in the white screen again? I've totally lost position of where we are. Can you see use salt question 15? Okay, good, because
Yeah.
that's what I'm, right. So let's look at what these questions look like. There are a whole bunch of them. So if I show you a couple, you really know how to do all of them, I hope. So find the Z such that 8% of the standard normal curve lies to the right of Z. So they're talking about Z's here. So let's show you what that guy is. When you talk about the Z score, aren't you looking at mean of 0, standard deviation of 1? So whenever they talk about Z score stuff, make sure that this is 0 and this is 1 and you'll be fine. Right? Now, and if you want to be in the top 8%, don't you go to the right and you make that number 8%. And the score that they're wanting then is a Z score of 1.4051, and then you round it off. Right. What kind of Z score do you need to be in the top 2%? Make that 2, right? When I click out, do you see that to be in the top 2%, you need to be a Z score of 2.0537, and you round it off to 2, 3, whatever decimal places they say. Suppose they ask you, what Z score do you need to be in the bottom 20%? Bottom, left L, 20%. And the Z score in that case is negative 0.84. Does that make sense? And can you see that a lot of these questions are probably only going to take you a couple of minutes each. So although there's a lot of them, they're not too onerous, I don't think, at least, in my opinion. So that's question, what 15 looks like. There's some practical ones. So let's finish off with the practical ones. The nursing medical staff are going to get a good laugh here because I am going to try and pronounce some medical words, and you know that they are, I think doctors do this deliberately so that they talk in their own language and nobody knows what the heck they're saying. So here goes. Porphyrin is a pigment in the blood protoplasm and other bodily fluids that is significant in body energy and storage. Let X be a random variable that represents the number of milligrams of this stuff per deciliter of blood. In healthy circles, X is approximately normal. So in a normal person, the average number would be 42, and the standard deviation would be an 11. Find the following probabilities. What's the chance that you get an X, right, that number, that protoplasm stuff, that is less than 60, then greater than 16, then a between 16 and 60, and lastly, more than 60. In this question, more than 60 is a kind of the magic number, which may indicate an infection or anemia or some other illness. So you get a bloody, you get a full body scan temperature thing, and you get your blood tested and everything else. And if this particular level is bigger than 60, you've got a problem and they want to maybe look into it. So I'm hitting salt. So it's not different from what we've done. They've just put a story behind it. And in this story, the mean was 42. And the standard deviation in this story was 11. And one of the questions was less than or equal to 60. So if I rub this out and I put in 60, the answer is, what, about 95% if you round it off. So 95% of the people are going to have a score of 60 or less. Now, what about greater than 16? Well, greater is right than. Then you type in 16. And greater than 16 is what? About 99% of the people are going to have a level greater than 16. The next one is between 16 and 60. So if you make that 16 and you make that as 60. Oops. Oh, I hit the wrong one. There's a between 16 and 60. And what about 94% of the population are going to be between 16 and 60, right? That's probably the normal range, right? For whatever reason. As long as you're in that range, you probably get nothing too serious. But this last person is going to be bigger than 60. So the percentage of people that that's likely to be true for is what, about 5%. So if you're in the top 5% with that particular blood thing, right, then they are going to look at that as, you may have an infection here. We're going to maybe look into it in more detail. So if you want to put in the temperature one or anything you know about, if you know the blood pressure and you know the standard deviation, can you put it here and here and then just play about with this number and figure out what it should be? Now, 5% is still 1 in 20 people, so that might be your doctor's a little bit worried. But I'm going to change this question. What about a 1 in 1,000 person? Somebody whose number is so high that only 1 in 1,000 people have it. So you probably got really serious issues here. I wonder what level that would transform to. And the answer is about 76. So if that level came back as a 76, you would be, you might even be in intensive care. I'm not quite sure how serious an infection could be, but according to that, it would be a very rare event, right? And so I think that's a good point for us to finish. Will you make sure you say hi so you get attendance?